प्यारे भाई और बहनों, वेलकम टू योर ओन चैनल ओनली साइंस। आप इस चैनल पर नए होंगे, प्लीज़ सब्सक्राइब द चैनल and click on the notification icon. Our time is very precious, so we start our chapter without wasting single minute. Now, our first topic is structure of the atom. Now we start introduction with activity. We have learned that atoms and molecules are the fundamental building block of matter. एटम्स एंड मॉलिक्यूल्स किसी मैटर के एक फंडामेंटल बिल्डिंग ब्लॉक्स होते हैं, जैसे गोल्ड फॉइल एंड एटम्स ऑफ गोल्ड के एटम से गोल्ड फॉइल की मैन्युफैक्चरिंग हुई, गोल्ड फॉइल की मैन्युफैक्चरिंग से गोल्ड की मैन्युफैक्चरिंग हुई। व्हाट मेक्स द एटम ऑफ वन एलिमेंट डिफरेंट फ्रॉम द एटम ऑफ अनदर एलिमेंट? क्या बनाता है एक एटम को दूसरे एटम से डिफरेंट एलिमेंट्स के? एटम्स हमारे रियली इंडिविजुअल हैं? We shall find out the answer to these questions in this chapter. Now we start with activity. Comb dry hair. Does the comb then attract small pieces of paper? Take a comb and comb in hair and take small pieces of paper. Comb attract small pieces of paper towards its surface. Rub a glass rod with a silk cloth and bring the rod near an inflated balloon. Glass rod attracts the balloon. Take a glass rod and a silk cloth. Glass rod rub on the surface of silk cloth. The glass rod attracts balloon towards its surface. From this activity, can we conclude that on rubbing two objects together, they become electrically charged? Yes, we know that. हम जानते हैं electrically charged object can attract an uncharged object. Where does this charge come from? Within the atom present in the comb and glass rod. This simple experiment tells us that some charged particles are present in the atoms of matter. So, the atom is indivisible. Now, we start study for discovery of electrons by Thomson's atomic model. Many scientists contributed in revealing the presence of charged particles in an atom. Discovery of subatomic particles. It was known by 1900 that the atom was not a simple indivisible particles but contained at least one subatomic particle. First, J.J. Thomson, a British physicist, was born in Chatham Hill, a suburb of Manchester, on 18th December 1856. He was awarded the Nobel Prize in Physics for his work on the discovery of electrons. He directed the Cavendish Laboratory at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prizes. Thomson's atomic model. Thomson passed electricity at high voltage through a gas at very low pressure, taken in a discharge tube. Streams of minute particles were given out by the cathode. Negative charge. Cathode means negative charge, anode means positive charge. These streams of particle are called cathode ray. कैथोड रे की वजह से जो स्टीम्स इमर्ज हो रही थी उनको कैथोड रेज बोला, बिकॉज दे कम आउट ऑफ कैथोड, क्योंकि वो कैथोड से आ रहे थे. कैथोड रे कंसिस्ट ऑफ स्मॉल नेगेटिवली चार्ज्ड पार्टिकल कॉल्ड इलेक्ट्रॉन्स. सिंस ऑल द गैसेस फ्रॉम कैथोड रे, it was concluded that all the atoms contain negatively charged particles called electrons. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like as a currants, means dry fruits, in a spherical Christmas pudding. Yes, just like in this figure. While the electrons are studied in the positively charged sphere, like the seeds in the watermelon. Watermelon seeds look like as a negative charge, and the rest of the part is positive charge. Thomson proposed that an atom consists of a positively charged sphere and the electrons are emitted in it. Like as watermelon. Watermelon seeds look like as a negative charge and rest of the part is positive charge. The negative and positive charge are equal in magnitude, so the atom as a whole is electrically neutral. Neutral means no charge. Characteristics of an electron. Mass of an electron. The mass of an electron is about 1 upon 1840 of the mass of hydrogen atom. The mass of an electron is so small that is considered to be negligible. Charge of an electron. The absolute charge on an electron is 1.6 into 10 to the power minus 19 coulomb of negative charge. The relative charge of an electron is minus 1. Now, Rutherford's Goldfoil experiment and drawback. E. Goldstein discovered the presence of new radiation in a glass discharge and called them canal ray. These canal rays were positively charged radiation. This subatomic particle had a charge equal in magnitude but opposite in sign to that of the electron. Its mass was approximately 2000 times as that of electron. It was given the name of proton. Protons means this is represented by capital P. Characteristics of proton. The two important characteristics of a proton are its mass and charge. Proton is positive charge and electron is negative charge. Yes, mass of proton. The proton is actually a hydrogen atom which has lost its electron. The relative mass of an electron is 1 U. Mass charge of a proton. The charge of a proton is equal and opposite to the charge of an electron. So, the absolute charge of a proton is 1.6 into 10 to the power minus 19 coulomb of positive charge. In other words, the relative charge of a proton is plus 1. A. Rutherford was born at Spring Grove on 30th August 1871. He was known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of the nucleus of an atom with the Goldfoil experiment. He got the Nobel Prize in Chemistry in 1908. Rutherford's model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for his. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. Alpha particles is a positively charged particle having 2 units of positive charge and 4 units of mass. Now, gold foil experiment. Take a source of alpha ray They are beam of positively charged particle. In front of the source keep a thin gold foil. This thin sheet made up of gold and keep screens to detect the alpha rays. This first ray passes through the gold sheet. Let's see the reason behind this by performing a simple experiment. Stand near a fence and throw a stone towards the fence. This first ray passes through the gold sheet. The first ray passes through the gold sheet. The stone passes through the fence to the other side. Why does this happen? There is a lot of empty space between the two planks of a fence, hence the stone passes through the fence. Similarly, in the gold atom, there is a lot of empty space from where the alpha rays passes. The second ray hits the gold foil and turns back. Let's see the reason behind this. This second ray hits the gold foil and turns back. The second stone hits the fence and turns back. Why does this happen? This happens because the stone hits the plank and doesn't allow the stone to pass through. Similarly, in the gold foil atom, there is a positively charged part which turns the positively charged alpha ray. Look like this. Majority of the alpha rays passes through the gold sheet. This shows that the part from which the positively charged alpha rays turn back is very small in size compared to the empty space. Conclusion of Rutherford's alpha particle scattering experiment shows the presence of a nucleus in the atom. It also given the following important information about the nucleus of an atom. Nucleus of an atom is positively charged. Nucleus of an atom is very dense and hard. Nucleus of an atom is very small as compared to the size of the atom as a whole. The radius of nucleus has been found to be about 10 to the power 5 times smaller than the radius of the atom. The relative size of the nucleus is an atom is roughly the same as that of a pea in the middle of this large stadium. Look like this. Drawback of Rutherford's model of the atom. The major drawback of Rutherford model of the atom is that it does not explain the stability of the atom. And any particle in a circular orbit bound undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atoms should be highly unstable and hence matter would not exist in the form of that we know. We know that atoms are quite stable.